Hi, I'm Dr. Jeff Rohde with Dental Compare. I'm here with Dr. Russell Giordano. He is the inventor of the new VITA material called Enamic. Dr. Giordano, thanks so much for your time.
You're welcome.
Now, as I understand it, it was in the 90s that you first came up with the idea for this material.
Right, the idea was to try to come up with a material that combined the best properties of ceramics and composite resins into one material. So that we would have a material that was wear resistant but wear kind, color stable, that was not brittle. The ceramics are still brittle even though they may be very strong.
Right. So being that you have an extensive background in materials, where did you start?
So we started looking at the ceramic network based on some of the powders that VITA was using at the time in their processing. We started pressing these powders into blocks and trying to make sure that we got the right connection between the particles, we got the right network. And then adding some different types of polymers into the pores that were left behind to get this interconnected network.
Right. So at the basic level, what's the composition of Enamic?
So it's you can think of like a ceramic sponge. So we're starting off with or coral. We're starting off with a ceramic network. It's all connected, porous like a piece of coral, and we're filling those pores in with a polymer. And the polymer is about 15% by volume. The ceramic is about 86%. And the polymer gives the material its flexibility. Everything else is based on the ceramic network. The color, the material strength properties, the stability, the flexibility, all are coming a lot from the ceramic.
Now, how does that strength property play into, when you consider how it's going to function in the mouth? Why is this different than just a traditional porcelain?
So if you look at a traditional porcelain or traditional ceramic, they may be very strong, but they're still brittle. So as a flaw develops in them, that flaw may propagate through the material and cause it to fracture. The way this material is designed is if there's a flaw starting in the material, it may go in between the particles, but eventually get stopped by the polymer or that interconnected ceramic sponge network that's in the material.
So the crack that started actually stops.
So it stops.
And can't continue through.
Right, it stops, can't continue. The energy is taken away from it and it stops.
That's amazing. So applications for this? Posterior teeth,
posterior
obviously?
Crowns, inlays, armlays, veneers. One of the big advantages of this material is you can mill it down to about 0.2 of a millimeter.
Wow.
So if you're looking at these no prep veneers or very thin veneers, you can mill that. Some studies have shown that you can get down to about 1 millimeter thickness, or even for posterior crowns.
Excellent.
Mill's very sharp, no chipping that you see in ceramics or even some composite resins.
Right. So this is available for if you have chairside milling, you can use this for that?
It's available for chairside milling. Laboratories obviously could also use it. I'm not sure what VITA's plans are for blocks for other laboratories like pucks or other things like that. But I'm sure that would not be an issue for them to make if they wanted to.
Well, Dr. Giordano, thanks for the introduction to this new material. It's pretty exciting stuff.
You're welcome.
Dr. Giordano introducing the new VITA Enamic material. Check it out.